Welcome back to this channel. This whole playlist will consist of videos about rock mechanics. Now, let's take note that rock mechanics is associated with geology as well as engineering. So, under engineering, we can say that rock mechanics is associated with what? Geotechnical engineering or even mechanics. What then is rock mechanics? Rock mechanics simply talks about the theoretical and applied science, theoretical and applied science of the mechanical behavior of rocks. What this means is that rock mechanics finds interest in studying every bit of information about what rocks rocks and rock masses. So under rock mechanics, you'll be finding information or you'll be studying more about how rocks will behave when loaded with forces. So how rocks will respond to forces or stresses that are being imposed on them. These forces or stresses are as a result of what? Environmental conditions. As geologists or as engineers, there is the need for us to study rock mechanics so as to ensure that there is stability and safety in the construction of geological or geotechnical structures. Let's then talk about the objectives of rock mechanics, what rock mechanics seeks to achieve. Now, the objectives of rock mechanics is in what? Three folds. So rock mechanics seeks to achieve three things. The first one being that it seeks to determine rock mechanics seeks to determine the properties of the rock, determine the properties of the rock and the rock mass, the properties of the rock and the rock mass associated with the project of interest. What this means is that if I'm to construct a geological structure or a geotechnical structure, I'll be using materials such as rocks. Now, the objective of rock mechanics is to know the properties or determine the properties of the rock that I'm going to use to construct this geotechnical structure. That's one objective of rock mechanics, to know the properties of the rock that I'll use to construct a geological structure of interest. The properties of interest may be physical properties, they may be mechanical properties, they may be thermal properties, or even hydraulic properties. In addition to these properties, the in situ stress fields needs to be measured as well. The intact rock and the rock mass properties are usually determined in the laboratory and in the field respectively. So under rock mechanics, we want to determine, let's say, let me just give a scenario. Let's say I want to construct this house, right? I'll definitely need some rock materials to do this. So what rock mechanics seeks to achieve is that it determines the properties, that's the physical properties, the mechanical properties, the thermal or even the hydraulic properties of the rock masses or of the rock I'll use to construct this house or a tunnel or a road or what have you. The second objective rock mechanics seeks to achieve is that so model and predict so rock mechanics model and predict the behavior of the rock mass, the behavior of the rock mass when subjected to new loads. So when subjected to new loads associated with the engineering structure to be built, sorry, associated with the engineering structure to be built. What this means is that rock mechanics seeks to know or it predicts and models the behavior of the rock mass that we are going to use to construct a structure. So let's say that again I want to construct a tunnel. Let's say I want to construct this, I have this rock mass and I want to construct a tunnel within, let's say I want to construct a tunnel within this rock mass. Okay, this is the rock mass. Now, what the objective of rock mechanics is that you like to determine or you have to model, you have to predict the behavior of this rock mass, the behavior, how this rock mass will behave when subjected to new. So, in modeling and predicting the behavior of the rock mass when subjected to new loads associated with engineering structure to be built, so you realize that this particular structure will be induced with what? With loadings. So now in rock mechanics tends to predict how this rock structure, this rock mass will react to the loadings. So when I construct a tunnel within a structure again, let's say the tunnel within the structure, the machines I'll be using to generate or to construct the tunnel within this structure will impose certain stresses on the rock mass. So under rock mechanics, we want to predict how this rock mass will behave. Now, upon completion, once the engineering function I want to construct is done, let's say if it's a tunnel, once I've constructed the tunnel, I want to observe and monitor the response and behavior with adequate instrumentation. So what this means is that once I've constructed a tunnel, let's say a tunnel in the rock structure, as time goes on, I'll have to monitor how the structure engineering, is behaving to the environment, how the structure is behaving, the response to its environmental factors, so as to prevent failure. In so doing, there is the need to use adequate instrumentation. So uh, some engineers do is they in the structure, in the construction of the structure, we put in certain, let's say for the tunnel, we put in certain sensors so that if there is any displacement, if there is any movement within the tunnel, it's being recorded by the sensors. So that's so in a short overview, the objective of rock mechanics is that the first one talks about the fact that the rock that I'm going to use to construct the structure, I want to know the properties of those rocks and those materials. The properties could be physical, mechanical, chemical, thermal, or even hydraulic. The second objective is that rock mechanics want to model and predict the behavior of the rock mass. So the rocks that we are using for the construction, rock mechanics want to predict its behavior when new stresses or new loads are imposed on it. And finally, rock mechanics after the structure has been built, rock mechanics intends to monitor and observe the behavior of the structure. And this is done with what? Adequate instrumentation. Let's proceed by talking about some applications, some applications of rock mechanics. So applications. Now, Rocks can be used as raw sources for construction materials. So rocks are used as they are used as raw sources for for construction materials. What this means is that the construction materials can, so meaning that rocks can be used as what aggregates. We can use rocks as aggregates. We can use rocks as construct, or we can use them for construction stones, and even for decorative stones, and many more. So many geological or engineering structures in the construction of the structures, we make use of what, of rock, and the idea of rock mechanics. Now, many engineering activities involve rocks either as construction or foundation materials, and some of these include, let's say now, in the design of foundation, design of foundation, let's say for tunnels, bridges, dams, and even towers. We employ knowledge in rock mechanics. Again, when we design let rock slopes, when we design rock slopes and surface excavations, we employ knowledge in rock mechanics. So the surface, let's say surface excavations for canals, for highways, railways, spillways, pipelines, pen stocks, dam abutments, pin pits. In all this construction, we employ what? Knowledge in rock mechanics. Again, underground excavations, when we design underground excavations, we employ knowledge to design of underground excavations. We make use of knowledge in what? Rock mechanics. Then we can also talk about design of design of structures, design of structures associated with design of structures associated with energy development. Design of structures associated with energy development. We employ the knowledge in rock mechanics. So some of these energy development structures includes the, let's say maybe when we want to construct an underground nuclear plant, or let's say we want to construct an underground storage, an underground storage to store nuclear, an underground storage for nuclear and chemical waste, nuclear and chemical waste. So these are some of the energy development structures. Yeah. So in designing such structures, we employ the use of, or we use knowledge in rock mechanics. Let's talk about some developments in rock mechanics. Now, the need for understanding the behavior of rock mechanics has been recognized by geologists and many engineers at the turn of the 20th century. So, at the turn of the 20th century, rock mechanics was recognized by so many engineers and mining geologists. Yeah. So, let's say as at 1957, geology, after 1957, rock mechanics became a separate discipline by the influence of Talorby. Yes, he wrote the first treatise, which made rock mechanics become a discipline on its own. Now, the advancement of rock mechanics was mainly by two occurrences, was mainly influenced by two occurrences. The first one being malperfect, the malperfect dam burst, which occurred as a result of an instability in the abutment of the dam, instability in the abutment of the dam. This killed 421 people. Now, it occurred in France. Yes, it occurred in France on December 2nd, 1959. After the Malpasset dam burst, another occurrence took place, which was disaster, the Virgin disaster, which also occurred as a result of what? A rock slide. As a result of a rock slide and killed 2,600, killed in Italy. Yes, killed 2,600 people in Italy on October 9, 1963. So these two occurrences led to the advancement of rock mechanics. That these two occurrences made people find interest in studying rock mechanics. The next thing we'll talk about is rock as an engineering material. Take note that most of our engineering materials, with the exception of timbers and soil, are tested and manufactured to specification. So, with the exception of timbers and soils, most of our materials are manufactured and tested to specifications. Now, however, rock is extremely old. So now, among all the engineering materials we have, rock is extremely old. Is extremely old compared to rock is extremely old compared to all other engineering materials. Extremely old compared to all other engineering materials. Its age is measured in millions of years, and it has undergone significant mechanical, thermal, and chemical activities. Now, you should also note that rocks are used as building materials, so the structure is likely to be built on a rock, to be built in a rock, or to be built with a rock. Now, what are some of the structures that are built on rock? We can build structures such as buildings on rocks. Now, in rock, we can build mine pits, or even tunnels in rocks. And with rocks, we can build dams and roads with rocks. So you should know that engineering structures are either built on rock, built in rock, or built with rock. So building on rock meaning that the structure is going to be constructed on the rock. Building in meaning that we are going to construct a structure in it. So let's say we'll be having a structure, a rock mass, then we'll build in the rock mass. And with the rock mass, let's say the rock is going to serve as the construction material where we are going to construct with it. I'll leave you with this few questions for you to try your hands on. What is rock mechanics? What are the three main objectives of rock mechanics? Name two occurrences that led to the advancement of rock mechanics. Then finally explain the term rebuild in, on, and with rocks. See you in the next video. Don't forget to subscribe. Bye.